Inverse functions. A fashion designer is traveling to Milan for a fashion show. He asks his assistant, Betty, what 75 degrees Fahrenheit is in Celsius. And after a quick search on Google, she finds the formula C equals 5/9 times F minus 32. Using this formula, she calculates 5/9 times 75 minus 32, approximately 24 degrees Celsius. The next day, the designer sends his assistant the week's weather forecast for Milan and asks her to convert the temperatures to Fahrenheit. At first, Betty might consider using the formula she has already found to do the conversions. After all, she knows her algebra and can easily solve the equation for F after substituting a value for C. For example, to convert 26 degrees Celsius, she could write 26 equals 5/9 times F minus 32. 26 times 9/5 equals F minus 32. F equals 26 times 9/5 plus 32, approximately 79. After considering this option for a moment, she realizes that solving the equation for each of the temperatures would get awfully tedious, and realizes that since evaluation is easier than solving, it would be much more convenient to have a different formula, one which takes the Celsius temperature and outputs the Fahrenheit temperature. This is the idea of an inverse function, where the input becomes the output and the output becomes the input. Inverse function. If f of a equals b, then a function g of x is an inverse of f if g of b equals a. The inverse of f of x is typically notated f inverse of x. So equivalently, if f of a equals b, then f inverse of b equals a. Important. The raised -1 used in the notation for inverse functions is simply a notation and does not designate an exponent or power of -1. Example 1. If for a particular function, f of 2 equals 4, what do we know about the inverse? The inverse function reverses which quantity is input and which quantity is output. So if f of 2 equals 4, then f inverse of 4 equals 2. Alternatively, if you want to rename the inverse function g of x, then g of 4 equals 2. Try it now. Given that h inverse of 6 equals 2, what do we know about the original function, h of x? Notice that the original function and the inverse function undo each other. If f of a equals b, then f inverse of b equals a. returning us to the original input. More simply put, if you compose these functions together, you get the original input as your answer. F inverse of f of A equals A, and f of f inverse of B equals B. Since the outputs of the function f are the inputs to f inverse, the range of f is also the domain of f inverse. Likewise, since the inputs to f are the outputs of f inverse, the domain of f is the range of f inverse. Basically, like how the input and output values switch, the domain and ranges switch as well, but be careful because sometimes a function doesn't even have an inverse function or only has an inverse on a limited domain. For example, the inverse of f of x equals square root of x is f inverse of x equals x squared. Since a square undoes a square root, but it is only the inverse of f of x on the domain, close parentheses, 0, infinity, open parentheses. Since that is the range of f of x equals square root of x. Example 2. The function f of x equals 2 to the x power has domain negative infinity, infinity, and range 0, infinity. What would we expect the domain and range of f inverse to be? We would expect f inverse to swap the domain and range of f, so f inverse would have domain 0, infinity, and range negative infinity, infinity. Example 3. A function f of t is given as a table below, showing distance in miles that a car has traveled in t minutes. Find and interpret f inverse of 70. The inverse function takes an output of f and returns an input for f. So in the expression f inverse of 70, the 70 is an output value of the original function, representing 70 miles. The inverse will return the corresponding input of the original function f, 90 minutes. So f inverse of 70 equals 90. Interpreting this, it means that to drive 70 miles, it took 90 minutes. Alternatively, recall the definition of the inverse was that if f of a equals b, then f inverse of b equals a. By this definition, if you are given f inverse of 70 equals a, then you are looking for a value a so that f of a equals 70. In this case, we are looking for a t so that f of t equals 70, which is when t equals 90. Try it now. Using the table shown, find and interpret f of 60, f inverse of 60.